Good morning. My name is Jadon Herron, and today I'll be presenting on operator math 1 and 2, and then also operator math 3 and 4. So it's going to be a total of 3 hours for operator math 1 and 2, and then if you stick with me, we'll have 2 additional hours this afternoon for operator math 3 and 4. So about me, I was born and raised in Union, Oregon. I went to college at Oregon State University, where I graduated with a bachelor's degree in civil engineering, and I have worked at AP for just over 7 years now. So a little humor here is I am an engineer. I can't spell that. I try a couple more times, and I finally just give up. And as an engineer, I am good with math. The other joke about engineers is we're good at solving problems you didn't know you had and in ways you can't understand. I'm sure most of you can relate to that. Goals for today. For the first hour, we're going to review some basic math concepts and units. We're going to review basic and useful math equations. Then we're going to put these equations to work with example problems. We'll then expand into everyday problems that you could encounter in your systems, and we're going to try and have some fun in the process. We're going to start with a little bit of math humor. So the question is to change centimeters to meters, and the answer here was take out centi. You take out centi from centimeters and you have meters. Next one here is we have a triangle trying to find the third leg, the x, and the answer was here it is, right here. Another one here, we have try to write a greater than or less than symbol. And the instructions were write or. So they write or in each of the problems. All right, that's about as funny as I can be as an engineer. So we'll go ahead and get started into some units. First, we're going to discuss some basic length, area, and volume. But length is a unit of measurement or extent of something from end to end. So it's a one-dimensional measurement. Feet, linear feet, inches, yards. Example is we replaced 400 linear feet of 3034 PVC pipe between manholes. Next one we're going to talk about is area. Area is the extent or measurement of a surface. It's a two-dimensional measurement. So examples are square inches, square feet, square yards. Examples are after the main line broke at 2 a.m., we had to repair 20 square feet of asphalt. Volume, the amount of space that a substance or object occupies. So this is a three-dimensional measurement now. So cubic feet, cubic yards, gallons. Example is this class may drive you to buying a gallon of whiskey. Hopefully we don't quite get there, but no promises. So some potential confusion about volumes, lengths, and areas. Example is he showed up with his 10-yard dump truck. So 10-yard sounds like a length, but we're actually referring to a volume of 10 cubic. Now let's talk about velocities and flows. So similar to areas and volumes, velocity is the speed of an object, distance divided by time. So feet per second, miles per hour. Example is during a fire flow, the water travels at 10 feet per second in the transmission. So how fast is that water moving? Now flow would be similar to like a three-dimensional measure. Flow is the rate at which a volume of a substance moves. So cubic feet per second, gallons per minute, million gallons per day. Example, when a large rain event occurs, the treatment plant sees flows increase to 1 million gallons per day. Concentrations. Concentration is the strength of a solution, the amount of dissolved substance in a given volume of solvent, typically in milligrams per liter, parts per million, or parts per billion. So if it is diluted, you do not have very much of a dissolved substance. And if it is concentrated, you have a lot shown in this diagram. with diluted being on the left and concentrated being on the right. Units, units, units. So over the course of the next 5 hours, we're going to be talking a lot about units, making sure units match and tracking our units through the problem. So in any problem, the units have to match. The data is given in different units. We have to use conversions to get all the units in the same before solving. And you'll see why this is so important as we start working through some example problems later. But always remember to track your units. Useful conversion factors. So we'll have a reference sheet. I wasn't able to pass that out, obviously, but we will be jumping back and forth on that reference sheet on our example projects or on our example problems. So some examples of unit conversions is 1 acre is equal to 43,560 square feet. 1 cubic foot is equal to 7.48 gallons of water. I guess this is just a straight volume, doesn't matter if it's water or any substance, but 1 cubic foot is 7.48 gallons. 1 cubic foot per second is equal to 448.8 gallons per minute. Okay, we've talked about some useful conversion factors. So now let's jump in and practice some conversion problems. So earlier I mentioned a reference sheet. I'm going to go ahead and bring that up. So the reference sheet I have here is the formula/conversion table for water treatment, distribution, and water laboratory exams. So this is the Association of Boards of Certification for Professional Operators. Now this is going to be the same cheat sheet that you'll have when you go in to take your exams. So I'm going to be referencing this throughout the math course. So with that, let's look at the problem we're going to be looking at. So conversion problem. A water storage reservoir is 200,000 gallons. How many cubic feet of water will this reservoir hold? So the first thing we have to do is we have to convert this from gallons to cubic feet of water. So looking at our cheat sheet here, I'm going to scroll down. And we have our conversion factors here. So we're looking to go from gallons to cubic feet, if we can find that. So here we have 1 cubic feet of water is 7.48 gallons. So let's try this. We know we have 200,000 gallons. Now we're going to multiply that by our conversion factor, which is in 1 cubic foot of water. We have 7.48 gallons. Now, what we see here is we have our units of gallons and our units of gallons. So when we multiply these, gallons are going to cancel gallons. We're going to be left with cubic feet. So if we do this, we'll have 200,000 divided by 7.48 is equal to 26,737.9 cubic feet of water. So our next problem is an effluent disposal irrigation field is 20 acres. What is the area in square feet? So we're looking to go from acres to square feet. And again, here's our conversion. In 1 acre, we have 43,560 square feet. So we have 20 acres times in 1 acre, there's 43,560 square feet. So again, we'll go 20 times the 43,560, and we get 871,200 square feet in 20 acres. And again, we're going to be tracking our units. So when we track our units, acres are going to cancel acres. We're going to be left with square feet. Moving on to our next conversion problem. A well pump produces 1,000 gallons per minute of flow. What is the flow rate in cubic feet per second? So we need to know our conversion to go from gallons per minute to cubic feet per second. So here's our conversion. We've got 1 cubic feet per second is equal to 448.8 gallons per minute. So again, let's start with what we know. We know we have 1,000 gallons per minute. And again, our conversion factor is going to be in 1 cubic foot per second. There is 448.8 gallons per minute. So again, our units, always tracking units, gallons per minute is going to cancel with gallons per minute. We're going to be left with cubic feet per second. So we have 1,000 gallons per minute divided by 448.8 gallons per minute per CFS. We get 2.23 cubic feet per second. So let's talk a little bit about problem solving. When we're working on problems, first thing we want to do is read the problem and figure out what you want to find. If applicable, you want to find the right equation, or in what we were just working on, the right conversion. Fill in the variables. And remember, always track your units. Then we're going to move forward and solve, plug and chug. So one of the useful methods is what are called pie wheels. So let's look at area of a circle. The way the pie wheel works is you have area of the circle on top, and the area is going to equal to 0.785 times the diameter squared. So what this circle, what the pie wheel is showing you is that area, this is going to be, let's say, in feet squared, it's going to be equal to 0.785 times diameter squared. So again, the way the pie wheels work is 1/2 of the equation is on the top half of the circle. So our area is going to be on the top half, while what that equals is going to be on the bottom half. So it equals 0.785 times our diameter squared. Now, it's real similar for the area of a rectangle. Again, we're going to have area, which is on top of the pie wheel, equals the length times the width. So again, we have area, one side of the equation, equals the other side of the equation, length times width, which is on the bottom half of the pie wheel. Next thing I want to talk about is order of operations. So this is another very important concept that we're going to harsh on today. So we're always going to be tracking our units. The other one is going to be order of operations. So the order of operations is parentheses, exponents, multiplication, division, addition, subtraction. Now another way to remember this is please excuse my dear Aunt Sally. So parentheses, exponents, multiplication, division, addition, and subtraction. Now the other way we've heard this is PEMDAS. So PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. PEMDAS. So we'll go over this over and over again today as we're moving through these example problems. So parentheses, what this means is we have parentheses 1 plus 2 times 3. So the way we would do this is parentheses first, 1 plus 2. One plus 2 is going to equal 3. Then we're going to have 3 times 3. So that's going to equal 9. Next is going to be exponents. So we have 3.14 times 2 squared. We'll do exponents first. So this is going to be the same thing as saying 3.14 times 4. 2 squared is equal to 4. And this is going to equal 3.14 times 4 is 12.56. Next, we have multiplication. So 1 plus 2 times 3. So we'll do the multiplication first. 2 times 3 is equal to 6 plus 1 is equal to 7. So we had 1 plus 2 times 3, follow PEMDAS. Multiplication happens first. 2 times 3, that's going to be equal to 6. 6 plus 1 equal to 7. Division is going to be the same order of operations as multiplication. So again, we have 1 plus 2 divided by 2. It's going to be the same thing as saying, we'll do our division first. So it'll be 1 plus 2 divided by 2, which is 1. That's going to equal 2. So again, we did the division first. So 2 divided by 2 is equal to 1. So this is the same thing as 1 plus 1, which equals 2. Then the last order of operations is the addition answer. Again, just remember, please excuse my dear Aunt Sally or PEMDAS. So let's work on another practice problem. What is the area of an 8-inch diameter PVC pipe? For this, we're going to assume that 8-inch is the inside diameter. So, again, Units, units, units. We've got to make sure everything is the same. So we're starting with an 8-inch inside diameter, but all of our answers are in square feet. So the first thing I want to do is I want to convert the 8 inches into feet. So 8 inches is going to be the same thing as 8 divided by 12 feet. So now, let's figure out the area. So area of a pipe is going to be equal to 0.785 times our diameter squared. So this is the same thing as 0.785 times 8/12 squared. So when we do this math, the first thing we have to do is the parentheses. So we do 8 divided by 12. Then we're going to take that, and exponents is next in our order of operations. So 8 divided by 12 is equal to 0.6667. We're going to square that answer, then multiply it by 0.785. We get an area of 0.35 feet squared. Now again, the reason why we have an area of feet squared is because this 8/12, our diameter, is in feet. So we have feet, the second power is going to be feet squared. Practice problem number 2. A wastewater facultative lagoon has a total area of 2 acres. The width of the lagoon is 350 feet. What is the length of the lagoon? So, what do we know? We know we have 2 acres, but our units aren't matching. So the first thing let's do is let's convert our acres into feet. We have 2 acres. Let's jump back to our cheat sheet, and we know that 1 acre is equal to 43,560 square feet. So one tricky thing here is when you see these conversion factors on the cheat sheet, you have to know where to put the 1 and where to put the 43,560. So again, we're always going to be tracking our units. So we know we have 1 acre in this conversion factor. So we want to get rid of the acres and get to square feet. So we'll put the acres on the bottom. So based on that conversion, it's 1 acre. That's equal to the 43,560 square feet. So again, we'll have acres cancel acres. We're going to be left with square feet. This is going to be equal to 87,120 square feet. Now you watch me, I'll write square feet a couple different ways throughout the day. So SF being square feet, you could also write it as feet squared. You'll see it both ways. I'll probably bounce back and forth, and I apologize for that. Okay, so now we know what our area of our lagoon is in square feet, and we also know that our width of our lagoon is 350 feet. So if we know our area is equal to our length times our width, we know what our width is. Our width is equal to 350 feet. We know our area Clean this up a little bit here. We know our area is equal to 87,120 square feet. So if we take our area, let's write this out. We have our area of 87,120 feet squared is equal to our length times our width, which was 350 feet. So what we'll do is we're going to divide both sides of this equation by 350 feet. When we divide the right side by 350, we'll divide the left side by 350. So take this, divide it by 350 feet. Take this side, divide it by 350 feet. And what we have is 350 feet on the right side is going to cancel. We're left with just the length. And then on the left side of the equation, we have 87,120 divided by 350 is equal to 249. Our units are going to be feet. We have feet squared on top, dividing that by feet. So feet squared divided by feet is equal to just feet. So our answer is 249 feet, going to be our length. Okay, let's move into our next useful equation and pi wheel. And this is going to be the volume of a cylinder. So again, the way the pi wheel works, we have the volume, which is the top half of the pi wheel, equals the components on the bottom half of the pi wheel, which is 0.785 times our diameter squared times our height. So if you recognize this, the volume of a cylinder is actually the same thing as the area of a circle, which is this component here, 0.785 times d squared. That's the area of a circle, multiplied by the height, and that's going to get us our volume. So let's practice problem number 3. How many gallons are in a pipe that is 18 inches in diameter and 1,165 feet long? So first thing you notice is we have inches, feet, and gallons. So let's start by converting the inches into feet. So we have 18 inches times in 12 inches, there's 1 foot. So 18 divided by 12 is going to equal 1.5 feet. Again, we have inches cancel inches, and we're left with feet. So our diameter is equal to 1.5 feet. Okay, now we have our diameter in feet and our length in feet. So we're going to try and figure out the volume. So a length of pipe is the same thing as the volume of a cylinder. So we'll start by calculating the area. So area is equal to 0.785 times our diameter, 1.5 feet squared. This is going to equal 1.5 squared. We're going to do our exponents first. Times 0.785 is equal to 1.76 feet squared. So again, our area is equal to 1.76 feet squared. Going back to our pi wheel, we have the volume of a cylinder is 0.785 diameter squared times height. But we just did the 0.785 times our diameter squared. So we need to multiply it by our height in order to get our volume. So we have so volume is equal to the area times the height, or in this case the length, which is equal to 1.76 feet squared times our length of pipe, 1,165 feet. We get 2,057.7, and this is going to be feet cubed. We had feet squared times feet. That's going to give us feet cubed. This would be a good time to talk about exponents. So when we have a unit that's feet squared times feet, imagine having a little number 1 up here on the foot. That's really what we're showing is feet squared times feet to the 1 power. So when you multiply feet squared times feet, we're actually going to add exponents. So 2 plus 1 is going to equal 3. So we have a volume of cubic feet, or feet to the 3rd power. So now, since we're tracking our units, again, we know we have 2,057.7 cubic feet, but now we have to take this and we have to convert it into gallons. So if we come back to our cheat sheet here, we know that 1 cubic feet of water is equal to 7.48 gallons. So we know we have 2,057.7 cubic feet times in 1 cubic feet, there's 7.48 gallons. So as we track our units, feet cubed cancel feet cubed. 2,057.7 times 7.48 is equal to 15,391 gallons. And, bear with me here. 15,391 gallons, if we round that up, is going to be C, 15,400 gallons. So this is another good time to talk about when we're tracking our exponents. We have feet cubed divided by feet cubed. They cancel each other out. So just like we did when we were multiplying feet squared times feet, we added the exponents. It's the same thing when we're dividing. So feet cubed divided by feet cubed, we're actually going to subtract those exponents. So if we have a 3, we're going to subtract this 3, and that gives us 0. So feet cancel feet, and we're left with just the gallons. Practice problem number 4. A water storage reservoir holds 500,000 gallons and has a diameter of 40 feet. How tall is the reservoir? Again, we have multiple units here. We've got gallons and feet. So we know we want our answer to end up in. So let's start by converting our 500,000 gallons into cubic feet. So 500,000 gallons. Going back to our cheat sheet, is we have 1 cubic feet is 7.48 gallons. And again, we know we want to put the 7.48 on the bottom because we want gallons to cancel gallons. That's going to leave us with the cubic feet. So 500,000 divided by 7.48 going to equal 66,845 cubic feet. And again, jumping around, CF versus cubic or feet cubed, it's the same thing. Now I want to know how tall is the reservoir. So again, the volume of the reservoir is going to be equal to the area times the height. So we know the volume. We know the diameter is equal to 40 feet. So we can calculate the area based on the diameter. So area is equal to 0.785 times our diameter squared. So this is equal to 0.75 times 40 squared. So 0.785. So again, the first thing we want to do is our exponents. So 40 squared. Multiply that by 0.785. This is going to equal 1,256 feet squared. Again, we're tracking units. Our diameter is in feet. Squaring it. So we're going to get an area that's in square feet. So now we know our volume. 66,845. We know our area. So we're going to take our volume, divide it by our height. Oh, excuse me. Back up here. We're trying to solve for height. We're going to take our volume, we're going to divide it by our area, and this is going to equal our height. So our volume was 66,845 cubic feet. Our area, 1,256 square feet. That's going to give us 53.2 feet. So again, we're tracking units all the way through the problem. As we talked about before, you have exponent divided by another exponent. That's feet cubed divided by feet squared. So again, we're going to do this exponent, 3 minus 2, is going to give us just a feet to the 1, or just straight feet. So feet cubed divided by feet squared equals feet, 53.2 feet. Okay, we're going to move into our next useful equation and pi wheels. This one is going to be flow rate. So our flow rate and let's just say in cubic feet per second. is equal to our area, feet squared, times our velocity in feet per second. Again, pi wheel, one side of the equation is on the top half of the wheel, the other side of the equation is on the bottom half of the wheel. So again, flow is just area times velocity. So moving into practice problem. A well pumps water at 1,000 gallons per minute. The discharge piping is 10-inch diameter. What is the velocity of the water through the discharge piping? So again, we have different units. We've got gallons per minute, we have inches, and we're trying to solve for feet per second. So we know our flow rate. So flow is equal to 1,000 gallons per minute. Now, our solutions are in feet per second, so let's convert everything into feet. So going back to our handy cheat sheet, we know that 1 cubic feet per second is equal to 448.8 gallons per minute. So 1,000 gallons per minute times in 448.8 gallons per minute is 1 CFS. Again, we're just tracking units. Gallons per minute is going to cancel gallons per minute. That leaves us with 2.23 cubic feet per second. So next, let's find our area. We know our diameter is 10 inches, but again, we want to solve everything in feet. So our area is going to be equal to 0.785 times our diameter, which is 10 divided by 12 to get us to feet squared. So again, if we're following PEMDAS, or the order of operations, we want to do parentheses first. We're going to do 10 divided by 12. That's going to give us 0.83. We're going to take that, we're going to square that answer. That's going to give us 0.694. We're going to multiply that by our constant of 0.785. We get an area of 0.54 feet squared. So now we have a cubic feet per second. We have a feet squared. So our flow rate and our area. Going back to our pi wheel, we know that the flow rate is equal to the area times our velocity. We're trying to solve for velocity, so we take our flow rate, divide it by our area, and that's going to give us our velocity. So our flow rate was 2.23. This was cubic feet per second. Now we're going to divide that by our area, which was 0.545 feet squared. Now, the reason why I'm drawing it out like this is the same thing as flow rate divided by area. So my flow rate is on top, my area is on bottom. But instead of just doing 2.23 divided by 0.54, I'm writing it out as multiplication of 2.23 times 1 over 0.545. The reason I'm doing this is because this allows me to track my units extremely easily. I have cubic feet on top, seconds on bottom, square feet on bottom. So when I track this out, my units are going to be equal to feet per second, because the feet are going to cancel the feet, so I'll be left with 1 foot on top and the second on bottom. So 2.23 divided by 0.545 is going to be equal to 4.1 feet per second. Round that, and that's going to be answer B, 4 feet per second. And if you're not quite following this, don't worry. We're going to be doing a lot of these practice problems today. So you'll see how we're writing these out and doing the division and multiplication and tracking our units through. Big thing is always track your units, and that's going to really help make sure you're getting the right answer. Moving on to practice problem number 6. A well pump is designed to pump 1,000 gallons per minute. Some engineer has told you that the velocity in the discharge piping should be 8 feet per second or less. What size should the discharge piping be? So we have a flow rate of 1,000 gallons per minute, and we have a velocity of 8 feet per second. So going back to our pie wheel, we got flow rate and our velocity. So what we can do is we can solve for our area. When we know our area, we can solve our diameter then. So again, we have 1,000 gallons per minute. Times in 1 cubic feet per second is 448.8 gallons per minute. Back in our units. And again, this is going to equal our 2.23 cubic feet per second. Now our velocity has to be 8 feet per second or less. So going back to our pie wheel, flow rate divided by our velocity is going to give us our area. So flow rate, 2.23 cubic feet per second, divided by our velocity, which was 8 feet per second. Okay, so this one's going to be a little tricky, what I just did. So I have the 8 feet per second. Now, I have 8 feet on the bottom. The second has to go on top. The seconds are going to cancel seconds. Feet cubed. Again, we're going to subtract exponents. So feet cubed minus feet to the 1 is going to be feet squared. So 2.23 divided by 8 is going to equal 0.28 feet. So that's our area. If you remember right, area is 0.785 times our diameter squared. Let me back up here. Feet cubed divided by feet is going to be our feet squared. So again, this is our area of our pipe. So again, we know our area is equal to 0.28 feet squared. And our equation is equal, our area is equal to 0.785 times our diameter squared. The first thing we want to do is we want to isolate our diameter. In order to isolate our diameter, we're going to divide both sides of this equation by 0.785. And 0.785 is just a constant, so there are no units to track with it. So the right side of our equation, 0.875, is going to cancel. And on the left side of the equation, we get 0.36 feet squared is equal to our diameter squared. Now what we need to do is we need to take the square root of both sides of the equation. So again, whatever we do on the right side of the equation, we have to do to the left side of the equation. So we're going to square root the left side, square root the right side. So 0.36 feet squared. So take the square root of that. And we get 0.6 feet is equal to our diameter. So when we take the square root of something squared, we just get the unit. So feet squared times the square root of feet squared is going to be feet. Square root of d squared is going to be d. But again, we have to convert this into inches. So we have 0.6 feet times in 12 inches. There's 1 foot. Feet cancel feet. Left with inches. 0.6 times 12 is equal to 7.2. Round that, it's going to be equal to 7 inches. So we know our pipe diameter has to be at least 7 inches in diameter. Now if we go over to our solutions, we don't see 7 inches. So now our two options for pipe size are going to be either 6 inch or 8 inch. But we know that our velocity has to be 8 feet per second or less. So if we go with pipe size smaller than 6 inches, we're going to be increasing our velocity. Now, if we go with a pipe size greater than 7 inches, we're actually going to be decreasing our velocity. So in that case, we want to choose C, 8 inches, because then we know we're going to have a velocity of less than 8 feet per second. Okay, so our next useful equation in pilot wheels is going to be loading rate and mass. So again, we have loading rate. Okay, I know what everyone's thinking. I've been harshing all day on tracking your units. Now all of a sudden we have a loading rate equation in pounds per day that includes million gallons per day, concentration in milligrams per liter, and a pounds per gallon. So how the heck are we getting a loading rate in pounds per day when our units aren't matching? So let's talk about that. So a parts per million is the same thing as a milligrams per liter. So by definition, 1 liter of water is equal to 1 kilogram or 1,000 grams. That's how much 1 liter of water weighs, is 1,000 grams. 1,000 grams is equal to 1 million milligrams. Therefore, 1 million milligrams is equal to 1 liter. So when we talk about milligrams per liter, we're actually talking about parts per million. That's why you can multiply million gallons per day times milligrams per liter times pounds per gallon and obtain pounds per day. So the units are canceling. So the milligrams per liter, parts per million, that cancels, so we get pounds per day when it's all said and done. Okay, let's roll into practice problem number 7. A water treatment plant is feeding an average of 295 pounds per day of chlorine if the dosage is 2.25 milligrams per liter, which is the number of million gallons per day being treated. So let's go back to our equation, which is loading rate in pounds per day is equal to flow in million gallons per day times our concentration in milligrams per liter times 8.34 pounds per gallon. So what do we know? We know that our loading is 295 pounds per day. And we know our concentration is 2.25 milligrams per liter, which, as we talked about, is the same as parts per million. So let's start filling in our equation with what we know. We know it's 295 pounds per day is equal to our flow in million gallons per day times our concentration of 2.25 parts per million times 8.34 pounds per gallon. Now what we're trying to do is solve for our flow in million gallons per day. So what we're going to do is we're going to divide both sides by the 2.25 parts per million and the 8.34 pounds per gallon. That way we can isolate flow in million gallons per day on one side of the equation. So what this will look like then is 295 pounds per day times 1 over our 2.25 parts per million. So again, I'm doing times 1 over 2.25 because I'm actually dividing by the 2.25. Now what I'm going to do is, since we talked about the milligrams per liter is equal to parts per million, so I'm going to have 2.25 parts per million. I'm also going to divide by the 8.34 pounds per gallon. So what that will look like is the 8.34 pounds per gallon. So now, when I multiply this through, this equals 15.7. Now let's check our units. We have pounds per day times million times gallons per pound. So our pounds are going to cancel. I'm left with million gallons per day. So MGD. Now that equals what we're looking for in million gallons per day, and also equates to A, 15.7 million gallons per day. So with that, that's going to wrap up our first hour of Math 1 and 2. And we will kick off our second hour of Math 1 and 2 here shortly. Thanks, you guys.